Okay, this is Algebra 1. Notes 18 says graphing linear equations. Make sure you put your name, date, and period. Our essential question is, how do you graph a linear equation? And to answer it, you say, to graph a linear equations, you pick 3 to 5 points to plug in and put it in the calculator and go to the table to see the points, and you graph it, and you'll plot the points, draw the lines to connect them, because these are now continuous graphs now. Alright, we have a few vocabulary words. This is a solution of a graph of two variables. These have two variables. They have an x and a y. And it says a solution will be one of the coordinates, which will be an x or y graph if you have an equation. We'll just substitute those values into it to find the answer. The second vocabulary word says graph of an equation with two variables is going to be the set of all points on the coordinate plane that represents all of the solutions. So this is where it's going to be continuous graph. Is we get to pick whatever points we want to put in there. It'll be a continuous graph when you get to pick them and you draw your line. Say a linear equation is equations whose graph is a line, and that's why these have changed to continuous with the linear equation. Standard form, it has the x and the y on the left hand side, and realize they have to be real numbers. Actually they have to be integers, and the front number must be positive, so we'll practice that when we get to it. The linear function means that you still have it in standard form, but it's a linear function because the b will never be a 0 when it's a linear function. Alright, if I go with example number 1, it says graph the equation. Here they give me the equation where it is not written in the form that we need it in. This is written in standard form. So I need to move the x to the other side of the equation. That's why we practiced it on Monday and Friday last week. So I'm going to write it over here on the side. In order to graph the equation, just so you know, this must be where the y is by itself, and then you have your x value plus some number. So you got to figure out what these values are, and that's why we were doing that on Monday and Friday. Okay, on this one we're solving for y, and to do so we got to move whatever is on the left side of my equal sign. Whatever is on the left besides the y has to move across to the left side. For this problem it has an x, and now there's an understood 1 in front of that x, and it happens to be a positive 1. So when I move it across the equal sign, it changes from a positive to a negative. And I'm not going to line it up underneath the 4. I'm going to actually put it just to the right of it, because the 4 is a constant number and the 1 is a coefficient. These are not the same things. And remember, it's a coefficient because it's attached to the x. It has a variable. So I want to bring this down. The x's are gone, but the y still exists. Equals, and then I can bring the 4 minus the 1 straight down, but proper form is that the x is first, so I'm going to rewrite it where the x, negative 1x, is first and the 4 is behind. The 4 was a positive 4, so it must have a plus sign. Alright, this is the equation I'm going to use to actually graph my picture. Here's my table. So as yesterday, we have the x and the y table. Remember, the x is your domain and the y is your range values. The domain, notice they did not give me the points. Did not give me any points. So I get to pick. And it does not matter what number you pick. You just get to pick. For me, a rule of thumb is I'm going to pick some easy numbers that are in my table, and see what kind of numbers I get. So I'm going to start with -2, -1, 0, 1, and 2. Because if you're doing this by hand and you're taking -2 and plugging it in and doing the math, that's an easier problem than if you pick 22 or 28 or some other number. And plus, these small numbers will typically be able to graph on our small graphs that we have here. If I picked a 28, it would not even be on my graph. It'd be out here onto the board or the table. Alright, so I picked small numbers, and I do need to have a negative and a positive and numbers in my choices, by the way. Alright, I'm going to grab my calculator. I'm going to go to the y equals like we did on note 17. Let me get the light out of there. I have -1x plus 4. I'm going into the y1. I'm only using y1 because this has two variables. These are two variable equations. And then I'm got to get to the table. I'm going to do a table set to make sure it starts at -2 and it's counting by 1. -2 and counting by 1. And then to get the table, remember, it's with your graph button and it's labeled blue, so hit second and graph so that I can see my table. And realize I have an x and a y, actually x and y1, which is where I put my equation. This says -2 is a 6. -1 is a 5. 0 is a 4, 1 is a 3, and 2 is a 2. So this represents my range of my problems. Okay, I'm going to set my calculator to the side. I don't need it now. These coordinates now, because these are actual coordinates, this is the x and y, so these are solutions to my equation. I want to plot all of these points. Remember, on your x and y axis, the x is the horizontal line, the y is the vertical. So -2, I'm going to start at the origin in the center. -2 means I go which way? Go left 2. And then a +6 tells me to go up 6. Put a dot. Okay, go back to the origin and go to -1, which means I go left 1 and up 5. Put a dot. Okay. Then I go to the next point. It says 0. 0 is right there at the origin. I don't move left or right. I just now look at the y coordinate and it moves up 4. Okay. Then I go to the next one. It has a +1. So from the center, now I'm going to go right 1 and up 4. I'm sorry, up 3. 1, 2, 3. Put a dot. And the last point will be 2 and +2. Okay, now you need a straight edge, and I don't have one right here by me, so I'm going to just use a piece of paper. And on this one, I'm actually going to draw a line. And to show that it is continuous, make sure you put arrows on the ends of your lines. Okay, if you don't have arrows, then that means it's discrete, and it'll be wrong. Okay, I'm going to slide it up. There's a little bit of news down at the bottom here that we got to watch out for. And that is when the graph is just a horizontal line or a vertical line. And here's the definition here that's kind of confusing. So the graph of y equals b is a horizontal line. So notice here that has y equals something. The horizontal line is y equals some number. It'll equal something. The vertical line has x equals something. So here it's got an a there. And realize it's referencing a point. The y coordinate, the y equals will always be the y coordinate. The x equals will always be the x coordinate. And these are creating horizontal or vertical lines. Also notice, horizontal line follows the x-axis, but the equation has a y equals. That's confusing. The vertical lines follow the y-axis, but the equation has an x equals. So they're opposite of each other, which is a very confusing concept. So keep this in your notes so that you can reference it whenever we get to horizontal and vertical lines. Okay, turn the page over so we can go to example 2. It tells us we're going to graph the linear function this time. We're saying it's a function. Here's our actual function, y equals, let me change to the orange pen, y equals 2x plus 2. And then it gives me a domain that I'm going to use. Now, first of all, is this equation written in the correct form that I can actually plug into my calculator? Okay. Do you remember my correct form? Was I had to have it in y equals form. This is my correct form for graphing. This is what I need, is it y equals and then everything else on the right hand side. Alright, so is this in the correct form? Yes, it is. It's good. So I don't have to do anything to my equation. I can actually go to my table. Remember, the first column is always going to be your x's, the second column is going to be your y's. And then I need to pay attention because it did tell me something about my domain. Because it says my domains have to be greater than or equal to 0. So I'm allowed to have 0. So my first number is going to be a 0. And then I need numbers bigger than 0. Well, I want to stay small, so I'm going to pick 1, 2, 3, and 4. Alright, I'm going to grab my calculator. Mine went to sleep, so turn it back on. Equals, I'm going to clear out the equation I had, and now I'm going to put in 2x plus 2. Okay, my table now starts at 0, so I'm going to go to my table set, and my start number, I'm going to change it to a 0. Still counting by ones. And now go to your table. Alright, 0 is a 2. I'm just going to copy it over. 0 is a 2. 1 is a 4. 2 is a 6. 3 is an 8. And 4 is a 10. And now I want to take my table and transfer it to the graph. First one, 0 and up 2. Next one is right 1 and up 4. Okay. Third coordinate is going to be right 2 and up 6. You should start seeing it form a line. Next coordinate is 3, 8. Okay. And next coordinate is 4, 10. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's right there on the top of my graph. Okay, grab your straight edge. Now, we got to be careful because this one said the domain has a limit. It starts at 0 and goes up. So that means it does not have any of the x values at all. So my line actually will start right here at this bottom one and then travel up. Okay, and I extended that up past my graph so that I made sure I put an arrow on the top end. I do not put an arrow on the bottom because it had a limit. Okay? Now, last thing, we got to identify the range. So I'm going to look at here. Here's my range. And typically you would say, okay, well this would be 2, 4, 6, 8, and 10, and you'd close it off. If you write this for this problem, this would be wrong. Because in this setup here, did they tell me the x's I had to use? The only thing they told me was I had to be 0 or bigger. I could pick any number that was bigger than 0 and plug in. I could pick 400 if I wanted. I could pick 4,000. I could pick 398,000. You know, something. I can pick any number and plug it in. Of course, I couldn't graph it on my picture, but I do know that it continues up and up and up and up and up. Keeps going. So that means my y values start here at this bottom number, right here, and they go up and up and up and up and up. It continues on up. It travels on and on and on up in the direction. That bottom number, I need to know what it is, which it happens to be right there in your table. Okay? Your bottom number that you are allowed to use is a 2. So I know all my y values, because y is my range. Okay? All my y values can be 2, but then they're going to be bigger than 2. So I have the equals, because it could equal 2, but then my numbers are bigger than 2, because it's a 4, 6, 8, 10, 12, 16, 18. Let's count by 2s. This will be your answer for this particular problem. Okay. On the last two, these are your independent problems. I forgot to type it on my paper. I want you to work these problems, and we'll check them in class. I'll give you about, probably, since we got 2, I'll give you probably about 5 minutes to work both of these problems, and then I'll check to see if you are graphing them correctly. Make sure you answer your summary on how to graph linear equations.